One of the most exciting space discoveries over the last 20 years was the confirmation that extrasolar planets exist. Astronomers as far back as the 1500s have speculated that there were planets orbiting other stars, but it wasn't until 1995 that the first exoplanet orbiting a main sequence star was confirmed. Since that groundbreaking discovery, over 1,800 new exoplanets have been identified and catalogued. Nowadays, it seems like every week astronomers are announcing the discovery of strange new planets orbiting distant stars. What are exoplanets? Extrasolar planets or exoplanets are simply defined as planets which exist outside of our solar system. Most of the planets we discover outside of our solar system are orbiting other stars, but exoplanets are not required to have a host star. They can go rogue, which we touch on further below. Why are we looking for exoplanets? One of the biggest reasons for our interest in exoplanets is simple curiosity. Studying planets in alien solar systems not only sparks the imagination, but it will also help us understand our own solar system. Comparative sizes of exoplanets. More than that, it also lays the groundwork for future science projects. Sometime in the distant future, we may want to send probes to explore our neighboring solar systems. Without knowing more about them, we won't know which systems would make the best candidates. Given the travel time and amount of money required for such an ambitious project, making certain that there is something worth studying becomes a requirement. Looking for exoplanets may also help us find extraterrestrial life. By discovering more Earth-like planets, SETI and other space agencies will have actual targets in which to focus their attention. We go into a bit more detail on the subject below. Why is it hard to find exoplanets? Until recently, discovering exoplanets had been an incredibly difficult task for astronomers. Even with access to the VLT, the Keck and the Hubble Space Telescope, astronomers were unable to make any progress. Despite being among the most powerful telescopes in the world, they just didn't have the resolution required to identify extrasolar planets. The reason for this difficulty is due to the brightness of the host star combined with the comparatively small size of the planets. Because planets give off very little light themselves, trying to spot an exoplanet is like trying to spot a firefly in front of a 100 million candle power commercial searchlight from 10 miles away. The glare from the star makes it an impossible task. Astronomers must use some clever tricks and indirect methods to identify and study them. So how do we find exoplanets? Astronomers knew that planets exert a gravitational pull on their host stars and were able to use that to confirm the existence of exoplanets. Extrasolar planet detection stars are massive when compared to even the largest planets, but every orbital system contains a barycenter, a center of mass. When a star has a system of orbiting bodies around it like exoplanets, the center of mass is not located at the very center of the star. Because of the offset location, it causes a slightly irregular but detectable wobble in a star. The more massive the exoplanet, the more noticeable the wobble in the star. This technique is called the Doppler method. The transit technique is an alternative method which measures the light from the star and attempts to detect a drop in brightness as a body passes in front of it. Unfortunately, this method is considered less reliable than the Doppler method described above. It is estimated that up to 40% of all detections made this way are false positives. Another method being explored for use in detecting rogue exoplanets is gravitational microlensing. Can we detect signs of life on an exoplanet? It may be possible. Planets which have the potential to harbor life as we know it would have specific concentrations of methane and other organics in their atmosphere. Most of the methane in our atmosphere is the result of biological processes. It is short-lived and would need to be continually replenished in a planet's atmosphere to be detectable. While not conclusive, if we detect that a planet has an atmosphere similar to Earth's, the likelihood of it hosting life rises significantly. To get an idea of what a planet's atmosphere is like, we use a technique called spectroscopy. This allows us to detect the makeup of a planet's atmosphere as it transits its star. We've already done this with large gas giant planets, but the resolution needed to study the atmospheric composition of an Earth-sized planet would need to be an order of magnitude more sensitive. Notable exoplanets. The cobalt blue gas giant. Cobalt blue exoplanet. HD 189733b is a Jupiter-sized planet located 63 light-years away in the constellation of Vulpecula. This exoplanet is notable because it's the first exoplanet which astronomers have predicted and verified its color, confirmed through two separate techniques: spectroscopy and polarimetry. HD 189733b is a cobalt blue world. Despite the cool blue color, the planet is very hot. It orbits extremely close to its host star, which causes the temperatures on the day side of planet to reach in excess of 1,800 Fahrenheit 1,000 Celsius. The deep blue color is thought to come from the planet's clouds, which are laden with reflective silicon particulates. Because the planet is so hot, astronomers believe these particulates to be like raindrops of molten glass. Planet Hell. HD 149026b is located roughly 256 light-years from Earth and is slightly smaller than Saturn. The planet is so hot, it shouldn't even exist. If you were to look at HD 149026b in infrared, it would shine like a star thousands of times brighter than Venus, the hottest planet in our solar system. Astronomers have calculated its temperature to be roughly 3,700 degrees Fahrenheit, which is just above the predicted limit. It's impossible for a planet to get this hot. So how did Planet Hell get so hot? Only an absolutely black planet could absorb enough light from its star to reach this temperature. If you were to view the planet from the night side, you would just see an empty black circle. No features would be visible. It would almost be like the stars were avoiding that part of the sky. If you were to travel around to the day side of the planet, you would immediately notice the planet beginning to glow red hot, like a smoldering piece of charcoal. Astronomers are baffled by the planet because there's nothing on Earth that can absorb so much light. Ocean planets. Water world planet. Despite their massive sizes, most gas giants are actually low-density planets. If you had a large enough bathtub, Saturn would float in it. Another type of a low-density planet is an ocean planet or a water world. These planets are believed to vary in size from roughly Earth-sized to up to 8 times the size of the Earth. One such planet is GJ 1214b, originally thought to be a rocky super-Earth. Astronomers now believe GJ 1214b to be an ocean planet based on revised measurements of its mass and incredibly thick atmosphere. The gravity on an ocean planet would be weaker, which would allow water vapor to evaporate easier. Over time, massive amounts of water vapor would accumulate in the atmosphere, causing the planet to have a thicker atmosphere than the Earth's, possibly thicker than Venus. This thick atmosphere would act as a blanket and make GJ 1214 be a very warm and steamy planet. The oceans on such a world would be hundreds of miles deep and make Earth's deep oceans look like a puddle by comparison. Diamond worlds. Diamond exoplanet. Carbon planets are high-density worlds. 55 Cancri E is suspected to be one such planet. 55 Cancri E orbits its host star very closely. A year on the planet lasts only 18 hours. Its tight orbit also makes 55 Cancri E a very hot planet, reaching temps in excess of 3,000 F. Taking into account its size twice the size of the Earth and its mass 8 times heavier than the Earth, and the composition of its host star, researchers have concluded that 55 Cancri E is a carbon-rich planet. Their research suggests that the planet appears to be composed primarily of carbon like graphite and diamond, iron, and silicon carbides. Researchers predict that at least a third of the planet's mass, the equivalent of 3 Earth masses, could be diamond. Forbes has estimated the value of the planet to be $27 million, 27 followed by 30 zeros. Rogue planets. Rogue planet in space. Planimus or rogue planets are extrasolar planets without a host star. These are planets that initially formed around a star, but due to having their orbits perturbed by other planets or even other stars, they were violently ejected out of their solar systems. These castaway planets are now thought to be extremely common. Researchers believe there to be at least 2 rogue planets for every star in our galaxy. Rogue planets would be lonely worlds, never experiencing a sunrise and existing in a perpetual night. Smaller planets would be frozen objects, very likely some of the coldest objects in our universe. However, that doesn't completely rule out life on these worlds. Leftover heat from the planet's creation may allow pockets of water to exist deep below the surface, and where there's water, there's a chance for life. Larger gas giant planets could have a system of moons not unlike Jupiter or Saturn. Tidal forces and friction from the massive gas giant may cause the interior of any moons in orbit to stay hot. If there are water on any of these moons, the warm interior could also provide an environment suitable for life. The chance of intelligent life on these worlds and moons is minuscule, but less complex life forms would find such an environment hospitable. The first exomoon was discovered by researchers in December of 2013. Pulsar planets. One of the most peculiar kinds of exoplanets we have discovered are pulsar planets. When a large enough star dies and goes supernova, the core is compacted and put under intense pressure. This breaks down the matter, usually iron, in the core at the subatomic level. What's left over from this process is an impossibly dense core made out of degenerate neutron matter. Due to the violent nature of their formation, and the energies involved, an intense rotation is imparted on the dense core. A rotation so fast, some neutron stars can make a complete revolution in just over 1.4 milliseconds. A supernova is an energetic and explosive event. When astronomers found not one, but 3 planets orbiting very close to a neutron star, they were baffled. Surely the supernova should have destroyed any nearby planets. Astronomers hypothesized that the planets actually formed after the supernova. They believe that there was a disk of debris that didn't quite escape the star's gravitational pull during the explosion and formed into planets. Exoplanets PSRB 125712a, BC are notable because they're not just the first exoplanets found orbiting a pulsar, they're the first planets ever found outside of our solar system. Astronomers Dale Frail and Alexander Wolskizin discovered these 3 oddities in 1992. Yoyo planets. Yoyo planet with extreme elongated orbit. Yoyo planets are planets which have an elongated orbit. An elongated orbit can take a planet as close into its host star as Mercury, then eventually swinging it out as far as Jupiter. These planets are especially interesting to astronomers because seasons on such a planet would be extreme. On Earth, our seasons are caused by the tilt of the planet and are considered mild. The seasonal changes on a Yoyo planet are caused by its irregular orbit. This creates seasons with an intensity like nothing we have ever seen here on Earth. When the planet swings in close to its host star, any water or oceans on the planet would boil off into the atmosphere. The massive influx of moisture and heat into the planet's atmosphere would create violent planetary storms. As the planet swung back out away from the star, the planet would cool and the water in the atmosphere would fall back down as rain or snow. Once the planet got as far out as Mars, the planet would become a frozen wasteland more desolate than Antarctica. There is a silver lining, however. For a few short months out of the planet's year, the planet would enter the system's habitable zone, Goldilocks zone. The Goldilocks zone is the area around a star where it's neither too hot nor too cold. Water can exist as a liquid and temperatures would be temperate. If the Yoyo planet was a rocky world like Earth, it may be possible for life to survive, even thrive. Life may have to hibernate during the brutal winter and adapt to survive the stormy summer months, but where there's liquid water, there's the possibility for life. Stay tuned as we will keep this page updated as exciting and strange new worlds are discovered. Thanks for watching. Please subscribe Space Facts channel to see more awesome videos.